So just like how you have graphs for linear functions, quadratic functions, exponential functions, so on and so forth, we also have graphs for trigonometric functions. So in this video, we're going to look at the graph for the sine function, and we're going to look at the vertical shift, we're going to look at amplitude and period. And if these things don't mean anything to you, don't worry, they will by the end of the video. We are not, however, going to look at horizontal shift. So if you would like to know about horizontal shift, this is probably not the right video for you. Alright, so let's begin. And when we start off, I would like us to just look at the most basic sine graph. And the most basic sine graph is y equals sine x. And I want us to look at what the key points are doing on this graph. So as somebody who's seen the sine graph before, I know what x values are important. So I know what domain I would like us to look at. So I will list the values in the domain that I would like us to look at. I would like us to start at 0 and then jump by 45 until we get to 360. So we're going to continuously jump by 45. Let me not write too big here because I would like it to fit. Alright, so we have 135, 180, and then we go to 225, 270, 315, and finally 360. Alright. So those are the x values that I would like us to look at, and once we see the graph, it will become clear why I selected those x values. Now, as for our y values, remember that y is equal to sine x. So we can plug into a calculator each of these x values into sine x, or we can use our triangle trick that we've learned, and we'll get that y, in this case, is 0. 45, sine 45 is 0.707 if you use your calculator approximately, or root 2 over 2 if you're doing your triangle trig. And then we keep going, we just keep plugging in, and we get again 0.707, and we have here 0 and negative 0.707. There we go. And then negative 1. Then back to negative 0.707, and as you may be noticing, it's kind of cycling around. What do I mean by cycling around? Well, let's take a look. So here's my axis. We're jumping by 45 all the way to 360, but I'll actually show you, yeah, well, let's plot it here. So we have 45, 90, 135, 180, 225, 270, 315, 360. All right, we got it to work here. All right, so the graph does, all right, so let's make this 1. Let's make this negative 1. And of course, 0.707 would be somewhere around here, negative. Okay, cool. So this is such a rough sketch. I don't have graph paper, and this is just a screen that I'm working on, but we'll do our best here. We have a point here at 0, 0. We have 1 at 45 and 0.707, so somewhere like here, and then it keeps going up, so it goes there, 135 and 0.707, so somewhere like there, and 180 is here with 0, 225, so we go down here. I'm sorry there are no numbers on my graph, it would just take a bit long to get those numbers in here. And there. Alright, so our graph is going to end up doing something like this. It cycles up, it goes down, it goes back. And so that's what the graph of y equals sine x looks like. So I'm going to pause for a moment just to tell you how important it is that you understand that this is the shape of the sine graph. This is the shape of the sine graph. You should know it like the back of your hand or the front of your hand or whichever part of your hand that you know the best. You should be able to draw it in your sleep. You should be able to draw it when you're awake. You should be able to just know that shape, because you're going to end up taking that shape. You're going to end up flipping it upside down, moving it up, moving it down, making it wider, making it thinner, making it taller, making it shorter. You're going to do all kinds of things with this shape. So you need to know the basic shape of y equals sine x. So just to stress it here, if there is no vertical or horizontal shift, it starts at 0, 0. So if it has not been moved up or down, it starts at 0. It goes up, it goes down, through the x-axis, then it goes all the way down to -1, and then back up to 0. So it starts and ends in the same horizontal line. All right, so if there is no vertical shift, it will start at 0, 0. But if there is a vertical shift, then you'll see the shift in where it starts. This will make sense in just a moment. So now that we know what y equals sine x looks like, now we're able to do things with it. So the general equation of a sine function is y equals a sine b x minus c plus d. All right, but as I said before, we are not going to be looking at a horizontal shift in this video. So for our purposes, oh, this should be closed. Oops, that's an eraser. Hold on. So for our purposes, the general equation that we will be looking at is actually not this, but pretty close. It's y equals a sine bx, so there will be no c, so we don't have to worry about c, plus d. All right, so the a, I'll define these things now and then we'll talk about them one by one. The a is the amplitude. The b is the number of cycles in 360. That's if we're dealing with degrees. If we're dealing with radians, it's the number of cycles in 2 pi. And the d is the vertical shift. In some books, you'll see d as c, but I call it d because later on you will have to learn about the c, and I don't want you to get confused. All right, so that's our vertical shift. Okay, so for this page, for now, let's just look at the amplitude. If we change it, what happens? So, looking at an equation, for example, y equals 3 sine x. So all that I've changed here is that a, the amplitude. So what you have to know about amplitude, amplitude is half the height. Amplitude is half the height. So let's just say height over 2. So for example, we have our sine curve. So as I said, you need to know the sine curve, the shape of it, like the back of your hand. And if you do, you'd be able to just go la 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 la. So easy. All right, so that's the shape. Now the amplitude, since the amplitude is 3, that means it's going up to 3 and down to -3. So it was quite simple because there was no vertical shift. This graph was not moved up or down. How do we know there was no vertical shift? Well, there was no plus d. There was no plus d, so we could just start at 0, 0, which is where the sine graph usually starts, go up to 3, down to -3, back over here. The graph was not made wider or thinner. We know that because there is no b, which means that, as you should know, the sine graph ends at 360. One cycle of it anyway. We could keep going with this if we wanted, because the sine function is what they call periodic. It just keeps going over and over and over. So one other cycle would end at 360 plus another 360. This would be 720. All right. So that's kind of how the sine curve works. That's how the amplitude of the sine curve works. But it can get a little more challenging if we're doing a vertical shift. So let's take a look at that. Okay, so on the last slide, we looked at the graph of y equals 3 sine x. Now we're going to introduce the vertical shift. So notice that there is something being subtracted over here. That means this vertical shift is a shift going 1 down. All right. So what does that look like? Well, let's see. So we have the graph of, let's actually move this up a bit because we might need the space. So we have our, oh boy, our coordinate plane here. And if we had the graph, and I'm going to do this in a lighter color because this is not the graph that we were asked to draw. We were asked to draw 3x minus 1. But this is, in fact, 3x, just the graph of y equals 3 sine x. It's what we just drew. But now with the vertical shift, that means we have to move this graph down 1. So instead of starting at 0, 0, it's going to have to start 1 lower. So it's going to start at -1. Instead of our high point being at 3, our high point is 1 lower at 2. Everything is 1 lower, so our low point is at -4. And the graph would then look like this. And again where it begins. So it started here and it ends here on the same vertical line. So this is a graph of y equals 3 sine x minus 1, whereas this one was a graph of y equals 3 sine x. So if you do have to do a vertical shift, it's helpful to draw the graph without the vertical shift first. You can, make it dotted, or you can use a pencil and erase it, or you could just use a lighter color, or whatever you choose to do. But that's not the graph you're being asked to draw. The graph you're being asked to draw is the one that is black. So then after you draw the first light colored dotted line, then you can move it down 1 or move it up wherever you need to move it up or down to. Alright, so that's how the vertical shift works. So let's look at our period and the number of cycles in 360. Okay, so as you can see here, there is now a number in front of the x. That number is the number of cycles in 360. It will also tell you the length of one cycle, and I'll get into that in a second. So here's how I go about drawing it in the easiest way possible that I can think of. I first sketch the coordinate plane, but I don't put the numbers in. And then I draw my shape. I draw the cycle. So I have one cycle of sine, another cycle of sine. Oh, that's not great, but we'll just pretend it is. And then we have another cycle of sine. So we have one ending here. Let me use a different color. One ending here, one ending here, and the last one ending here. We have 3 cycles of sine. All right, which means that we have 3 cycles of sine in 360, because remember that's the number of cycles in 360. So that 360 is out there, which means that since there are 3 of them in 360, this has to be 120, 240, and 360. All right, the length of one cycle, that's a word that we should actually, there's a word for that, one word for that. Length of one cycle, aka the period. In this case, one cycle ends at 120, so the period in this case is 120. The shortcut for finding period, there is a formula for that. Period is equal to 360 over b. So in this case, our b value was equal to, let's see right here, 3. So it's 360 over 3, which is 120, which is in fact what we got our period to be. So that is how you figure out the length of one cycle. We did not put one important thing on this graph though, and that is the amplitude here, where the graph goes up to and down to. Well, there is an amplitude of 2 and there is no vertical shift, which means that this is going up to 2 and down to -2. A little bit messy, but you see what's happening, hopefully. All right, so let's look at one more example. And in that one example, I'm going to try to introduce like little elements of this that I neglected to show you throughout the quick explanations in this video. All right, so I tried to make this one a little bit more fun, little weird things happening here, but our definitions are still the same. In this case, our amplitude is -1. And that just means that the shape of the graph is going to be flipped upside down. So when you have a negative amplitude, instead of going up, the sine curve will go down. And you'll see what I mean in just a second. This still is the number of cycles in 360. And it still tells us what the period is in the same exact way. And this is just our vertical shift. All right, so let's actually look at what this graph looks like. All right, so I'm going to draw my coordinate plane here. And I'm going to also work in a really light color because there is a vertical shift, and I do not want to draw my vertical shift right away. I want to see what the graph looks like first. So according to this right here, there's half a cycle in 360. I'm just going to draw a whole cycle. So remember that since the amplitude is negative, it goes down first instead of up. That's a pretty ugly graph, but that's okay. All right, and now there's half a cycle in 360. Half a cycle ends here, which means that that is our 360, and that is in fact 720. All right, and this is not the actual graph, right? Because there is a vertical shift. So, but I will label what we have so far. Since our amplitude is -1, it goes down to -1 first, and then up to 1. All right, now we can shift this vertically up 1, which means we needed more space, but that's okay. We'll just fake it here. All right, so our highest point will be 2, and our lowest point will actually be 0. So we're going to just start off 1. Let's use a different color. We're going to start 1 higher, go down, go up, and then we end up in the same horizontal place that we started. All right, so this is the graph of y equals negative sine half x plus 1. Okay, cool.